This is Sarah Wilkinson from Humber College and the University of Guelph Humber. In this video, I'm going to talk about pressure-volume relationships in the human body, specifically with regards to lung volume, as well as pressure-volume relationships in blood vessels. Pressure is the force exerted by molecules within a given volume. We see here we've got a container with molecules in it. These molecules are always going to be in motion, and they're going to be exerting pressure. If we have the same size container with more molecules within it, they're going to exert more pressure. So more molecules in the same volume of space, higher pressure. A really simple example of this is a balloon. A balloon that has lots of gas molecules on it will exert pressure on the side of the wall. Whereas if it starts to deflate, there's not as much pressure, there's not as much gas within that balloon. We could say the same thing for if water was filling this balloon. If there's lots of water, high pressure, little bit of water, lower pressure. When we talk about volume-pressure relationships, we call this Boyles Law, in that pressure and volume are inversely related, as long as the number of gas molecules does not change. So to simplify this, I've got two containers. They have different volumes. The one on the left is larger, while the one on the right is smaller. They both have the same number of gas molecules. We can see here that the container that has a larger volume has a lower pressure. So therefore, higher volume is inverse to lower pressure. When one goes up, the other goes down. So if we take the container on the left, shrink its size, we can say that the volume has gone down, but the pressure has gone up. This happens all over your body. Let's take blood pressure, for example. Here, I've got a small artery, or what we call an arteriole. There's going to be blood passing through it. Blood pressure is the force of blood on the walls of the blood vessel. So as blood passes through this artery, there's going to be pressure exerted on the wall. And if you think about it, there's really two factors that affect blood pressure. And I'm simplifying here, but really two main factors. The first is the amount of blood passing through this space. And the second is the size of the lumen. So we'll go a little bit more depth into this. So if there's more molecules in the same volume, there's a higher pressure. So if we have a low flow of blood, there's going to be a lower pressure. If there's a high flow of blood with the same amount of space, there's going to be a higher pressure. Secondly, if the volume increases but the number of molecules is the same, there's a lower pressure. So if we take this size of a container and we make it larger, there'll be a lower pressure. The same thing happens in your blood vessels. If I take a given volume of blood passing through this and all of a sudden I make the blood vessel larger, there's going to be a decrease in pressure. So same volume going through, but that volume will exert a lower pressure in a larger size of blood vessel. This becomes really apparent when we talk about the condition called atherosclerosis, which is essentially a fatty streak or fatty deposit in the blood vessel. What this does is this fatty deposit basically makes the lumen of the blood vessel smaller. So the size of the blood vessel has gotten smaller with the same amount of blood flow going through it. Therefore, blood pressure has gone up. If we look at air pressure, there's really two pressures we're really concerned about when we talk about ventilation or breathing. The first is what we call atmospheric pressure, and this is the pressure of the mouth. The second pressure we're concerned about is the pressure in the lungs, and we call this intrapulmonary pressure, the pressure within the lungs. And the difference between these two is really going to determine airflow. There's really two factors that affect intrapulmonary pressure: how much air is in the lungs and the size of the lungs. I'm going to go through this in more detail in a future video on ventilation. So lung volume can change when we breathe, and this is going to affect pressure and therefore airflow. In my next video, I'm going to further discuss pressure-volume relationships when I go through how air and blood moves in the body.